14, getting closer to that final one. This is, we're asked to graph a logarithmic function. So we've got this graph, this logarithmic function. We need to find 2 points on the graph and then also draw the asymptote. First of all, we can think about asymptotes. So if you remember, and if you don't, we're going to graph it here, what a logarithmic function in general will look like as it comes down from negative infinity. This is where your asymptote is, and it's going to go like that. And so your asymptote is right here, the y-axis. That's where we're going to put it. If there's something else going on inside here, like log b, whatever, the 3, it's not really all that important. If we're moving that asymptote, we would add or subtract something in here to move it to the left or right. Always good to take the graphing calculator. Let's go ahead and graph this. So y equals, we're going to do 4. For the logarithm, if you have this feature, what we could do is log base 3. If you've got an older calculator, you won't be able to do this, but I'll show you in just a moment. So log, and then the log base is down here a little bit. There it is, log base. So now you can put in log base 3 and x. We're going to graph it. And just to show you that the red and the blue will be the same, if you don't have the log base in your calculator, you have a TI-83, those are the older ones, or an older TI-84, you might not. So what you do is you do a change of base 4 times. And what you would use is you could use log base 10, but I'm going to use the natural log. So it's natural log of the input, which is natural log of x, divided by the natural log of the base. So this is a change of base formula. You can use this if your calculator does not have the log base. And what I'll show you is when we graph this, let's go zoom standard just to make sure we've got the right window. There's the blue, and the red is almost on top. But it's not exactly the same. What did I do wrong? 4 times. Oh, I've got an extra, I have an extra parentheses in here. I put my own where it gave me one. So I want to get that out of there. So there's that. That was the whole problem. It was grouping this wrong. That's why it's nice if you have the log base. And watch, when I go now, they are actually identically the same. And you can see the asymptote there at x equals 0. Right, so we have to put in an x and y value. X will be 0 for the asymptote. Y can be anything we want it to be. Draw it. It's hard to see, but it is a dashed line there, so that's in there. Then we need 2 points, and a nice point to usually pick up with the logarithms is if you put in x equals 1, you will get the logarithm to be equal to 0. Another way to verify that is if we go to the table, table set. I've got it on ask. I want it back on auto from an earlier one that we did. And let's -4 is fine. We'll start there. You'll see that those are undefined. Oops, what did I do? Table set auto. Doesn't it? Okay, I'll go to 0. Let's see. Now when I go to the table, there, that's what I was looking for. If I go backwards, I get errors, right? Because you got negatives or you've got zeros, you can't put those in. But if you got 1, you got 0. Okay, and notice I've got both of these are going to give us the same value. So I'm going to choose the points that are nice numbers to work with. We'll go with 1 and 0 and 3 and 4. Okay, so those are the 2 numbers I'm going to put in. 1, not 1, 1, 1, 0. Plot that point. Then I can plot the next one, 3 4. That point is plotted. Oh, I thought it was 3, 4. Plot the point. Maybe there we go. And now I click on this and I get the graph. Okay. How do you do without a graphing calculator? Well, you should have one, first of all. Alex is not going to give it to you. But what you could do is you could, for the ones that you're going to have to remember is this base is important. So for any logarithm, log of 1 is going, when you plug that in, that becomes 0, the log of any. And what that comes from is, remember, these are inverse functions. So 3 to the 0 will be equal to 1. These are going to switch places. That's why we always get 0. No matter what's here for, that's going to give us 0. The other one that's important is if you do the log of what the base is, right? So the 3, that's 3 to the first power. The answer is going to be 1. So, and again, we're multiplying the inner part here becomes 1. 1 times 4 is 4. Okay, so that then we can pick up that's where the 0.34 came from. So you can do this without a calculator, but again, the goal is that you learn how to use these graphing calculators. The next number that would have been nice would have been 9, because 9 is 3 squared, so it's 2 times 4, which gives you 8. That's how logarithms work. And then after that, you're looking way down. What's 3 to the third power? 27 before you get a nice number. So there's only a few that work well. Okay, so that gets us number 14.